Hello, and thank you for joining us today for this latest Tekla Structural Designer webinar, in which we'll be discussing the Chasedown analyses performed during the design concrete process. If you would like to ask a question at any point during the session, you can add this using the questions section of the webinar interface. We will try to answer as many of these questions as we can at the end of the session, and any questions requiring additional investigation will be covered via email after the conclusion of the session. My name is John Stevenson from the Trimble Solutions UK Services team, and I'll be leading you through this Tekla Structural Designer webinar today. Our topic for today's session will concern the analyses that are run as part of the design concrete and design all processes in Tekla Structural Designer. This is a subject that can cause some confusion, and the intention of this webinar will be to investigate and clarify the differences we may see in the results between the different analysis types, and how these differences will affect the design of the members and panels in a 3D concrete model. We'll begin by discussing what will occur during the design concrete process. In this section we will outline the conditions that are present in the analytical model for each of the analyses and how these will relate to traditional pen and paper models used for the design of structures. Next, we will investigate the differences we may see in the different analysis types and consider how this may affect the design of our members and panels. This will allow us to see the relative advantages of the different analysis types used during the design process and direct us towards the appropriate results for the situations we may find in a 3D structure. We will then finish by reviewing what has been discussed in the session for each of these analysis types. The first thing we will need to consider is what is occurring when the design concrete process is run. When this command, or the analyze all and design all commands are performed, the software will automatically run three different analyses. These will be the 3D building analysis, the Grillage Chasedown, and the FE Chasedown. After running the design process, we can right-click on any concrete member within the model and check the member to review the design results. By expanding any of the design result items, we can then see the three analyses will have been performed and the design results based on the critical analysis result from the three. This will be indicated by the blue exclamation mark in the results summary. We will now look to define what the 3D building analysis is and why we use this. The 3D building analysis would represent a three-dimensional version of a traditional frame analysis. During this analysis, the structure will be considered as one whole analytical model, with each level free to displace. The results of this will be that the forces within the members will include the effect of lateral displacements, known as sway effects. These can occur under gravity loading due to an eccentricity between the centre of mass and the centre of stiffness within the model. And these displacements will change the distribution of forces and moments within the members, as the beams and columns would act like a sway frame to resist the lateral movement of the structure. As these levels will be free to displace, second order effects can be considered, as we will have the column displacements, which will be the basis of our big P delta effects. If we're looking at a floppy frame system, these second order effects can represent a large increase in the design forces calculated by the software, so having an analysis in which these can be considered is important for the design of the structure. By default, the slabs within the 3D analysis will be unmeshed, and this will allow the slabs to act as diaphragms, which will result in the lateral load in the system being transferred to the stability systems, such as our core walls or braced bays. Using a diaphragm to do this ensures the stability systems are used for resisting the lateral load and are designed for the correct forces. Any load applied to the slabs will be decomposed directly to the supporting members without considering the effect of the bending resistance of the slabs. This will allow for a worst case loading to be decomposed to the supporting beams by forcing these members to take all the load that has been applied to the slabs. This means that by default there will be no forces and moments in the slabs, so these slabs will not be designed using this analysis. Next we shall consider the Grillage Chasedown analysis and how the analytical model used will differ from that of the 3D building analysis. The Grillage Chasedown analysis will perform a level-by-level analysis of the structure using single-floor submodels. The vertical load will be applied to the top level first, and the forces and moments in the members calculated using the tributary area method. The forces in the columns and wall panels will then be turned into reactions using artificial chase-down supports. These support reactions can then be applied to the columns and walls on the next level, and the process repeated for that level and the following levels as the load is chased down the structure. This method of analysis would be similar to a level-by-level subframe analysis that would traditionally be done using the tributary area method. In this analysis, the slabs will be used for the decomposition of loading, applying the load directly to the supporting members and wall panels, similar to how it would have been done in the 3D building analysis. The artificial chase-down supports will prevent any lateral displacements of the submodels, meaning that there are unlikely to be any significant second-order effects, either from bending in the columns, our little p delta effects, or from column sway, our big P delta effects. In this case, the Grillage Chasedown will behave as a first-order linear analysis with negligible lateral displacement at each level. Finally, we shall look at the analytical model that is used for our third analysis, the FE Chasedown. The analytical model for the FE Chasedown will be similar to those used for the Grillage Chasedown, using the same single-floor submodels and using the same method of applying the load to the lower levels through artificial chase-down supports. The difference in this case would be that for the FE Chasedown, the slab panels will be meshed during the analysis. This means that the slabs will be able to resist the applied load in bending, giving us the moments in the slabs that can be used for the slab design. The reactions at the edges of the slabs will then apply the forces to any supporting members. As the slabs will not be able to displace laterally, the design moments in the slabs will be for the gravity forces only, meaning our slabs will not be designed to resist lateral forces, and the forces will be similar to the traditional floor plate analysis method. So where might we see differences in the analysis results for the model? We shall start by investigating the effects of sway on the moment results for a concrete frame. The frame we shall consider will be frame number 3, and if we duplicate a view of this frame and place the new view in a separate vertical tab group, we should be able to review the results for the building analysis and for the Grillage Chasedown side by side. Right-clicking on the tab will present us with the commands to duplicate the view and to move this to a new vertical tab group. And then in the top left-hand corner of our results view, we can select the Grillage Chasedown analysis. So viewing the results for the frames side by side, we can see the effect that the sway displacement will have on the analysis results. From this, we can see that during our 3D building analysis, the frame will be resisting some of the lateral displacement. This changes the shape of the moment diagram, leading to a sagging at one end of the beam and hogging at the other. This would be contrary to what we'd be expecting for a beam under gravity conditions, but would represent the moment distribution of a frame resisting sway from lateral loading. Looking at the results of the Chasedown analysis, we can see that by preventing the lateral displacement will lead to getting a moment distribution closer to what would be expected from a beam under gravity-only conditions, with hogging occurring at both ends of our beam members. Without the additional Chasedown analysis, the hogging would not have been considered at one end of the beam, and by running both the 3D building analysis and Grillage Chasedown, we can consider both of these situations during the design of our structure. Next, we shall consider the axial force in transfer beams. For this we shall consider the frame along grid line 1, and by again duplicating this view and moving it to our second vertical tab group, we can view the results for the first order linear analysis or 3D building analysis and the Grillage Chasedown side by side. During the 3D building analysis, the column nodes will be free to displace vertically. At this location, the connected beams will also be able to displace vertically, leading to bending within the members. The bending resistance of the beams will then contribute to the resisting force in the column, and that additional bending resistance will therefore reduce the axial force within the transfer beams, leading to a smaller moment in our final transfer beam. With column nodes unable to displace during the Grillage Chasedown, the bending resistance of the beams will not be considered. We can see this by the lack of moment within the upper beams. The result of this is that all of the force will remain within the transfer column, leading to a larger force in the column where it connects to the transfer beam. You can see this if we look at the axial force results. So this larger axial force within the transfer column is going to transfer a larger force to our transfer beam at the bottom, leading to a critical force within that transfer member. By running both the 3D building analysis and a Grillage Chasedown, we are able to consider both the additional bending within the beams due to the vertical displacement of the column within the 3D building analysis, and the larger axial force applied to the transfer beam during the Chasedown analysis. So the next effect that we will consider will be differential axial displacement. This is an effect whereby the columns in the model will be significantly weaker than the nearby wall panels. With the columns free to displace, the weak columns will then shed the load back to the stiffer wall panels. So for this section I'm going to be looking at the results along frame number 4. Then by duplicating this view and moving it to a new vertical tab group, we can compare the building analysis results to our Grillage Chasedown results. So viewing the moments for the 3D building analysis, we can see that the column displacement and bending is leading to sagging throughout the beam member, and this implies that the weak column is not able to provide the support that would be expected from the column at the mid-span, and this is going to allow the column to shed the vertical axial force back to the stiffer wall panels. If we compare this to the results for the Grillage Chasedown, we can see that by preventing the vertical displacement in the columns, the results will look more like the central column is supporting the beam. We can tell this from the hogging moment that's occurring where the beam and column meet. So by preventing the vertical displacement in the column, we're able to prevent the effects of the differential axial displacement, and the column will now be taking the expected axial load during the analysis. Next we shall consider the differences in behaviour between the 3D building analysis and the FE Chasedown analysis. As discussed previously, during the 3D building analysis, the slabs will be used for diaphragm action and load decomposition only. If we wish to see the results for the slab, we would therefore need to mesh the slabs in order to include the effect of the slab stiffness during the analysis. So this can be controlled in the 3D analysis using the Mesh Two-Way Slabs in 3D Analysis property found under the Levels heading in the structure window. This option is intended for use with slabs that are required to act in transfer, supporting members such as columns or wall panels, and for unbraced concrete frames, where the slabs are intended to contribute to the lateral stiffness of the model through framing actions. So I'm now going to run the first order linear analysis and view the effect that this will have on the results for the model. So if we run the 3D building analysis with this option selected, the results for the model will show bending in the slabs and columns, as the mesh will lead to framing action between the slabs and columns and the wall panels. This will increase the lateral resistance of the model, which will reduce the lateral displacement results. Reducing the lateral displacement will reduce the force carried to the core wall systems, or for braced bays if we were looking at a model with bracing, leading to smaller moments and forces within those stability systems. If we intend for the stability systems to resist the lateral movement, this will result in incorrect reduced forces being used to design these stability systems. If we also focus on the deflection results for the columns, we can see that where the slab and column connect, the framing action between the column and slab will lead to a rotation at the column node. This is going to result in a change in the moments within the column due to that framing action. So I'm now going to uncheck the option to mesh the two-way slabs in the 3D analysis. And if I now select the Analyze All process from the Analyze tab, we should be able to run the first order linear analysis and the FE Chasedown analysis together. This will now allow us to compare the results between the 3D building analysis and the FE Chasedown. So looking at the 3D building analysis results, we can see that without the slab mesh, the results is the lateral movement of the structure will have increased. This will provide us with the correct diaphragm forces and thus moments in the wall panels for the design of these stability systems. A similar effect will be seen in other stability systems such as brace bays and moment frames. And as the slab is no longer acting in bending and we're not seeing the framing action, we can see the deflection profile of the column is now consistent rather than having the rotations at each of the levels. If we now review the FE Chasedown results, we can see that we have the moments within our slab items for a gravity-only condition, neglecting the effect of the lateral motion within the model. These results can then be used to design the slabs for a similar gravity-only condition that would be used for our traditional floor plate analysis. So we're now going to review what we've looked at in those models. So the first thing that we looked at was we were investigating the effect that sway displacement will have on the results for our frames. In the 3D building analysis, the lateral displacement will change the distribution of moment in the frames, and the columns will act more like a sway frame under wind loading. By running the Grillage Chasedown analysis, we're able to see the symmetrical results that we would expect from a gravity-only analysis. So in this case, the results from the Chasedown will match the expectations for a subframe analysis, while the 3D building analysis results will match the results for a sway frame. When considering the transfer beams during the 3D building analysis, we saw that we'll get a contribution to the resistance of the transfer forces from bending within the beams, as the column is able to displace vertically. This reduces the force that's applied to the transfer beams, leading to a reduced moment within the transfer member. Running the Grillage Chasedown will neglect the effect of the vertical displacement, leading to a critical axial force applied to the transfer beam. By considering both the beam bending and direct axial transfer, the members can be designed for both scenarios. In the second model, we saw the effect of weak column members relative to the stiff wall panels during the 3D building analysis, and due to the ability of the weak columns to displace, we saw that these can then shed load back to the wall panels. Preventing these displacements in the columns will allow the column to support the beam as expected, and leads to hogging moments in sections of the beams supported by the columns, as we would expect from a gravity-only analysis. From this we can see that the results of the Grillage Chasedown will represent a close approximation of a traditional gravity-only subframe analysis when compared to the 3D building analysis. These differences are seen due to the analytical conditions and restraints that are applied to the Chasedown submodels during the analysis. Both analyses will represent an approximation with assumptions about how the model will behave. The results are correct for the constraints that are applied to these situations, and they'll both automatically be considered during the design concrete process. It's also worth noting that the examples shown have been created to demonstrate these effects, and that you'll be unlikely to see such extreme results in a real model, but understanding the behaviour will allow you as the user to appreciate the differences in the results. In the model looking at the FE Chasedown analysis, we saw that while using the mesh two-way slabs in 3D analysis will allow us to consider the moments in the slab panels, this will alter the moments and forces seen in the rest of the model, as the reduced lateral displacement will reduce the force transfer to the stability systems. This will lead to an over-design of the slab panels and an under-design of the wall panels under the lateral forces. By using the FE Chasedown, we are able to obtain the moment results for the slabs without the additional framing action during the 3D building analysis. This means the slab will not be designed for the framing action due to lateral displacement, and the correct forces will be transferred to our stability systems. So concluding this section, the FE Chasedown will represent a close approximation of a traditional gravity-only floor plate analysis, and this will allow us to design the stability systems for the correct diaphragm forces and prevents the over-design of slabs due to framing action. We thank you for joining us for this session and welcome any comments and feedback regarding the content discussed. You can contact the support team by email at tekla.support.uk@trimble.com or by phone on 0113 887 9790. We will now look at some of your questions that you have sent in during the session. Any questions requiring either specific examples or further investigation will be dealt with via email after this session is closed.